Hi, in this video, I will be showing you problem number 37 of chapter 10, section 3. Sketch the curve with the given polar equation by first sketching the graph of r as a function of theta in Cartesian coordinates, r equal to 2 cosine of 4 theta. When we do polar graphs, it's better to know how many petals will there be when the argument is even coefficient, and the argument when it is odd coefficient. So here the argument is 4 theta for cosine. So 4 is an even number. If it is even coefficient for the argument, then the number of petals would be twice that number. If this was 2, the number of petals would be 4. If this was 4, the number of petals would be 8. If the coefficient, the argument coefficient is odd coefficient, then the number of petals would be the odd number. The argument, the coefficient of the argument. So, if you have cosine of 3 theta, for cosine of 3 theta, there will be 3 petals. For cosine of 4 theta, it will be 8 petals. And then now first we are starting off with the Cartesian equation, Cartesian graph. So cosine of 4 theta, this period is 2 pi over 4, which is equal to pi by 2. What it means is between 0 and pi by 2, between 0 and pi by 2, you will have one complete cycle of the cosine graph. So you notice here, between 0 and pi by 2, you see one complete cycle of the cosine graph. Then if you want to do the graph up to 2 pi, then you can repeat the graph. So for up to 2 pi. So a Cartesian graph is shown here. The amplitude is 2 and then the period is pi by 2. Now we are going to convert this Cartesian graph to polar graph. So you notice here between 0 and pi by 2 there is one cosine cycle. So it's possible to divide between 0 to pi by 2 as 0 and pi by 8 and then pi by 4, 3 pi by 8 and pi by 4. You get 5 points like that. So first it starts off with when theta equal to 0 it is 2. So on this line theta equal to 0 you are marking 2 units for r. So it is 2 comma 0, r comma theta, r is 2, theta equal to 0. Then at pi by 8, the graph actually decreases and goes to 0 at pi by 8. So pi by 8, it goes to 0. So you get this piece of the graph. Then between pi by 8 and pi by 4, the graph is on the opposite side, it's negative. So we have pi by 8, and then pi by 4 in that piece. So we are here pi by 8, opposite side is 9 pi by 8 part. Then pi by 4 in this piece, the graph is actually negative. So it comes to 2 in the negative direction. It takes up that part. Then between pi by 4 to 3 pi by 8, that is we are in this quadrant, pi by 4 to 3 pi by 8. If r was positive, the graph would be traced in this part, but r is negative here. Pi by 4 to 3 pi by 8, the graph is negative, but it is increasing from 2, it is actually increasing. It goes from 2 to 0. It goes from 2 to 0. Between 3 pi by 8 and pi by 2, the graph is increasing and becomes positive. So between 3 pi by 8 to pi by 2, it becomes positive. and it goes to 2. So one cosine cycle between 0 and pi by 2 gives these pieces of graphs. So if you complete the graph, you will get 8 petals. Put this Cartesian to polar. You notice here 0 to pi by 8, the graph is decreasing. So it goes from 2 to 0, 2 to 0 at pi by 8. Then between pi by 8 and pi by 4, the graph is on the opposite side. So it's actually decreasing and decreases to negative 2. So between pi by 8 and pi by 4, you're going to the opposite direction. So it goes to negative 2. And then pi by 4 to 3 pi by 8, it comes back to 0, slowly increasing. Then 3 pi by 8 to pi by 2, it goes to 2. So it goes to 2, which is at pi by 2, it becomes 2. So that completes one cosine cycle. So you are going to repeat that for all the cycles up to 2 pi. So you get 8 petals the way it is shown in the graph. Hope this video helps.